All right, hello and welcome back. If you watched the previous video I posted on this channel, you might see something familiar here. I actually still have the instance from my previous video sitting here stopped. So what I did in the previous video, in case you didn't watch it, was I set up an Ubuntu 24 desktop environment, and I set it up so that I can access it remotely using ThinLinc, which is a really cool piece of software that lets you remote into a Linux desktop in a very similar way to what you would do with remote desktop on Windows, meaning you have working bidirectional clipboard, you have working sound forwarding, you can share local files to the remote machine by mounting a folder, all that good stuff like you would have in remote desktop. So really cool piece of software, very cool tool. That's now installed here. I now want to go a step further and actually set the machine up to do something interesting. And what we're going to do is we're going to run Android Studio. So let's assume for a minute that for whatever reason you can't run Android Studio locally, but you do need to run Studio and also run the Android emulator and see what's showing up on the emulator in a GUI. Well, great. That's where you would need an Ubuntu machine like this with ThinLinc installed, ready to go. There is a problem though. This instance type is not going to work for us. We're going to be installing Android Studio plus the emulator, and the emulator requires hardware accelerated virtualization to work. That's not possible on most classes of EC2 instance. So we're going to have to switch to one of the metal instances, specifically a C5.metal, which is one of the cheaper ones, which is not to say that it's actually cheap. It's about $4 an hour. So obviously this is just going to be as a fun experiment. If you're really genuinely doing Android development day to day, you're probably better off buying a laptop and installing Ubuntu on there. Or in that case, you could even use Windows or Mac OS and run Android Studio from there. So this is just going to be sort of a proof of concept. What if you needed an Android emulator plus Android Studio in the cloud? Well, again, at least for the emulator to work, you're going to have to be running on a metal instance, because then you can do hardware accelerated virtualization. So that's what we're going to do. We're going to go check this little box here next to our instance. We're going to go to the actions menu, instance settings, and we are going to change the instance type. So see this option right here about 1/3 of the way down the menu, change instance type. I'll click on that, and we're just going to directly change this to a C5.large, or excuse me, C5.metal. Make sure it's a metal type. And you'll see obviously major price difference. My previous class, the X large, cost me about 16 cents an hour. This is going to cost me more than $4 an hour to run. And obviously, because the assumption is you're going to be running a really heavy duty workload, these tend to be very, very big machines. You can see here, this one has 196 gigabytes of RAM and 48 CPU cores. So probably way more than I need for this project, but this is already one of the smallest metal types available. So I click change. That'll go ahead and do my change for me. You can see that the instance is still in the stopped state. None of its other properties have changed, except the instance type is now C5.metal. And that's a really, really cool thing about clouds like AWS is I don't need to now redo any of my other settings. My security group settings, my network settings, my disks, all that stuff remains the same. Obviously, I'm going to get a new IP address, a new public IP when I boot this up, and the instance type has changed, but everything else is the same. The instance ID hasn't changed. None of the other settings have changed. So I can just boot this right up and it should work. So let's go ahead and do that. We will start the instance by going to instance state and clicking on start. I should say there is going to be a little bit of a performance difference in the starting and restarting process now. The .metal instance types typically take a lot longer to boot up and become operational compared to the other EC2 instance types. So just be aware that things that were previously fast, like restarting or doing a cold boot, will now take significantly longer because additional checks are taking place to get the instance into a ready state. So with that in mind, I'm going to go ahead and skip ahead to the point when this instance is actually fully booted and ready to go. So I said boot times were slow for metal instances, which is true. So how do I know when I'll be able to log into the thing? How do I know when the instance is actually ready? Well, the instance state is not super helpful here. It lists the instance as running even before it's actually fully booted up. So I need some other way to do a test. Probably the simplest way is to click on the connect button and see if Session Manager is ready. If this button here turns orange like this, it means Session Manager is ready and running and has reached out to the Systems Manager service, which means the machine's probably pretty much done with its boot process. I can do this because I used the official Ubuntu 24 AMI image, which actually includes Systems Manager agent, the SSM agent, and therefore I know that Session Manager will be able to connect to the instance, all other configurations being correct. Okay, so let's click on connect. We'll connect into the instance and just make sure that I can log in as the Ubuntu user and get a shell. Once we've done that, we're going to switch over and actually use ThinLinc to connect because we really want that desktop. We want a GUI environment so that we can install and use Android Studio. All right, so I'll do sudo su ubuntu. Great, I can get there. Everything looks totally fine. So let's switch to another screen here and we'll get ThinLinc up and running. All right, so again, I've got my server hostname plugged in here. I've got my username plugged in. I've pointed ThinLinc at an SSH key that corresponds to the one used by this EC2 instance. Now all I need to do is click connect and that will open up ThinLinc. Of course, it's going to complain about the host identity changing. That's not unexpected. The public IP has changed, so it does actually look like another machine from ThinLinc's perspective. That's okay. I'll just click on connect as I just did, and then we'll be able to connect up and get into that desktop. Okay, so you can see here we are. ThinLinc looks like it's working. I'll double click to sort of bring it up so it's closer to being full screen. We'll click on start, and that will connect us to our Ubuntu session, hopefully. Okay, very fast. It better be. It's got 96 virtual CPUs and more than 190 gigabytes of RAM, so one would expect it to be fairly fast. Let's now go ahead and download the Android SDK and get it installed. So let's see, the first thing we want to do here is go ahead and Google Android Studio. And there's the download page, so we'll go ahead and download that. The latest edition here is Ladybug. We'll fetch that one. I have to agree to the very long Google terms and conditions, so scroll all the way down to the bottom of that. All right, that might take us a moment, so wait for me to drag that all the way down. Yes, I've read it. Okay, go ahead and fetch. Now we'll download it for us. Installing is pretty straightforward, as you'll see in a minute. They do have an install guide for Linux, so if you want help with that procedure, if you look around for Android Studio Ladybug Linux install, I think that should surface the docs. There's obviously a lot of YouTube videos that cover it as well, but we'll just go straight to the written docs, and you'll see they've got the Linux instructions here. And actually, one thing they mention is that you should install these 32-bit libraries. I was not able to find any of these in the package repositories for Ubuntu 24. And given that most phones today are 64-bit, I'm not actually sure when you would need to build 32-bit Android software. I'm not an expert Android developer though, so maybe one of you watching the video knows the answer to that. For now, I'm gonna ignore this step. So even though the documentation tells me to install those extra packages, I'm not going to. I don't really think that that's actually necessary, so I'm gonna skip it. All right, so you can see here we've actually already completed the download. It was quite fast. I'm going to open up a terminal window so that I can unpack the Android Studio package and installer. So grab a terminal here, terminal, click on that. Okay, downloads. And I will do, I don't need this Thunderbird folder. I don't even know why that's there. All right, tar xvzf to unpack. We'll do Android Studio. That will unpack the whole thing for us. Okay, so it's all unpacked. We can now move on. One of the things we need to do is put Android Studio somewhere that's on our path. If you look in Android Studio here, there's actually, you don't really install it, right? If you go into the bin directory, there is actually just studio.sh. There's literally a script here that runs the studio, and it will just run in place as is, considering that it's basically just a giant Java application. Okay. So I'm going to move this. So let's actually move this somewhere else. Just for the sake of my own sanity, I like to put this kind of stuff in opt. So let's do sudo move, and we will move Android Studio into /opt. Sorry, opt. Great. And then what we're going to have to do to actually be able to use it is change our path so that our path includes opt Android Studio bin, which is where that studio script is. So we'll do that. Hold on just a second. We'll do vim /bash rc. Fantastic. And we're just going to throw this on our path. So only Shift G to get to the bottom of the file here. I'll do export path equals $path, and we'll throw onto the end of that opt Android Studio bin. And that should do it for us. So we'll now do source -rc to load that in. Whoops. And if I run Studio, that should now just go ahead and start up Android Studio. It will go through the welcome. This will just decide what components should be fetched and included. I'll click next. I'm going to go with the standard install. If you really know what you're doing, you could pick custom. I will let it fetch all of this stuff for me. It's a little bit more than a gigabyte of stuff, so it will take a little while. I'll accept the agreement, next, and then we just say finish. Great, and it should go ahead and start downloading that. And again, I'm not going to make you sit here while it does that. We'll come back in a minute once it's done. Great, and it looks like it finished with no issues, so I'm going to hit the finish button here, and we're now ready to start a new project. Let me close some of this stuff we're not using. I'll close Firefox. I'll leave this terminal open because that's where the studio is running from. I'll make this a little bigger. The IDE is running with enabled input methods that can cause freezes. Okay, let's disable those. Hopefully that helps. Actually, you know what? Just a usability thing. If you have set up ThinLinc to create a remote desktop like I've done here, you may find that some of the accessibility settings in Ubuntu cause issues. I've had issues with control keys getting stuck down when I'm in the ThinLinc session. If you click on the power button and then click on the little setting gear cog like I just did, that will open up the system settings, and you can then go down to accessibility. And if you go up a little bit, hold on a second, I actually think it's in typing. Yes, so open up typing. So again, from accessibility in the settings, you go to typing, and this repeat keys feature, I don't know why, but for whatever reason, when I turn that off, things work a little better for me. So I'll turn that off, and I'll click close, and now we'll go back to Android Studio, and I'll make a new project. So I'll click on new project, and empty activity is the one we want. That's an easy one to get started with, so we'll do that. I'm going to call it greeting. Greeting is a good name. Actually, this empty activity isn't completely empty. You'll see in a minute that there's sort of a hello world example built in that we can utilize. So we'll be starting with that, and I'll click finish. Okay, great. And once it finishes building the project, we should be able to actually take this and just compile it and deploy it to an emulated phone. So you'll see name is Android, padding is inner padding. There's some elements here that say hello and then your name, right? So there's already existing example code sitting right here ready to go. If I were to click run, I should be able to actually run this. Oh, it's actually not going to let me. Before I can do that, I'll have to select, I believe, the entire project. So let's right click on that. Oh, I see what the issue is. Sorry. If you look way at the bottom here, we actually have not finished importing the whole Gradle project for our app here. So it actually needs a little bit of time before it will be ready to build. So let's give it a second. And actually, you know what? While we're waiting for that to finish, let's go over and look at our devices. So there's no running devices. Let's go to Device Manager here, which is this little Android icon next to a little phone up in the corner here. And you'll see they've got this medium phone as sort of a built-in. I actually don't like this one very much. My experience testing on this sort of generic medium Android phone was that things ran pretty slowly. So I'm going to delete that, and I'm going to replace it with a Pixel 9. So let's do create virtual device, and we'll choose a Pixel 9. And I'll say next, and it's going to tell me what it needs to fetch, which Android images are available for that phone. Next, I'll give it a name. Pixel 9 API 35 is fine. And we'll save it here. And let's see if it actually runs. I suspect that it will not, but we can give it a shot. Dev KVM device permission denied. Okay, yeah, so that's an issue. So when we first set this machine up, we actually did not set it up in a way where the Ubuntu user has permission to do any of this hardware accelerated goodness, right? We don't have permission as the Ubuntu user to access dev KVM, which is something that we have to have in order to run this virtual phone. So how do we fix that? Well, I need to go back to my terminal here, and we'll open up a new tab, and we're going to add our current user to that group. So I'll say sudo add user KVM. So now they're in the group that is allowed to use KVM. So what we'll do is we'll actually reboot. And I should say, for the reboot here, probably the best way for us to do it, the fastest way, is going to be to choose reboot from the instance state menu here in the EC2 terminal, which is why I switched over to this window. I'll say reboot, and then again, we will wait a little bit, then try and connect back in over Systems Manager, Session Manager. Once I'm able to get in that way, I'll know that I can go back into ThinLinc and reconnect to the desktop. All right, so it's been about 10 minutes. Let's go ahead and click on the connect button. We're finally ready. All right, great. So that means the instance is good to go. Let's just make sure we can get into a shell, make sure everything looks normal. Okay, things seem to be up and working. So let's go ahead and switch over to ThinLinc. All right, so we're back in business with the ThinLinc client. Let's go ahead and click on connect and see where that takes us. Hopefully that will bring us right back to our desktop. And if everything has gone correctly, we should now be able to have access to dev KVM, which means that we will be able to start our emulator and actually run our little Hello World app on that emulated phone as well. So let's go ahead and do that. And you know what? Let's make this a little bit bigger. Like before, I'll open the terminal and type in studio. Studio. There we go. And that should fire up Android Studio for us. Wonderful, blazing fast. All right, so it's started, it's ready to go. Let's try our Pixel API virtual device again. I hit the play button. Aha. So good things appear to be happening. You can see that we are now connecting to the emulator, and this little icon has come on here, which indicates that the microphone has been activated, which makes sense because what should happen is this virtual device should be able to talk to our speaker and microphone. So you can see it's booting up. Things look like they're working. The very first time it boots up, it might take a little while. Whoops, sorry. Let me not deal with this system problem. Cancel that. First time it boots up, it might take a little bit. So let's give it some time to get booted up before we actually build and run our app. Okay, so it looks like it's booted up and it appears to be working. So let's try running our little test app here. I'm going to hit run app, which should force the app to build and run on our little virtual Pixel 9 here. So let's let that happen. You can see if you look, I'm getting all these helpful tips from the IDE that are taking up a lot of screen real estate. But if you look at the very, very bottom of the screen, let me just squeeze this over a little bit so it doesn't take up so much space. If you look at the very bottom of the screen, Gradle build running. So our app is in fact getting built right now. And in a moment, it should auto load onto this virtual device and run there. So you can see it now says launching on devices at the bottom. That's a good sign. It means that the app build has finished. And a little hard to see, but way up here at the top it says hello Android. So it built and it ran. It did the thing it was supposed to do. And just to prove that this really is like a fully featured emulated Android phone, let's go ahead and go back to the main menu here. Let's navigate my way back to the app menu. We'll hit the virtual home button there. Let's open up YouTube and see if we can play a video and have sound and all that. So I'll pick a video at random and we'll see where we get. BBC, nature, baby corgis. All right. Look at them, they're so cute. All right, so we go down, we click on the corgi video, and let's see if it loads up and plays. Oh, I'm getting an Amazon ad, how about that? All right, so let me close that. Can we flip the phone around? I think we can. Let's rotate the phone. So we've rotated the phone a little bit, and let's squeeze our code window over as well so we have more space for the emulated device. I want to see a bigger screen. Okay, got it. Yes, thank you. Close this Wix ad. Click on the skip button, and let's see if we get our baby corgis. Let me check my video settings real quick. I think I may have forgotten to turn the audio on. So let's flip the phone around. Take it out of full screen. Whoops. Didn't mean to hold it upside down. There we go. All right, media volume's up to max. And I've got my media volume up to max here in ThinLinc as well. Let's see what happens. Perfect. So it's a little choppy, but we can even get audio from our remote EC2 instance running the Android emulator in Android Studio. It all works. Granted, this is, again, an extremely expensive way to solve this problem. You're probably better off installing Android Studio locally if you can. But if for whatever reason you have to have a full, completely remote, cloud-based Android Studio plus Android emulator solution, this will do it. All right. That's all for this video. I'll see you in the next one.